So welcome back. I'm Alan J and welcome to Lincoln Central with your 16th amazing trig tutorial in the Basic Trig series. In this tutorial we'll be looking at two ways of calculating triangle area and working through some simple common problem types. The first and simplest way of calculating triangle area is from its base and height. To appreciate how this works, we inscribe the triangle in a rectangle like so, and drop a perpendicular from the apex at the top to the base. This divides up the rectangle into two smaller ones. As you can see, each rectangle is divided by the diagonals into two equal halves. If you look closely, you'll see that the triangle area is made from two half rectangles in blue and green. The area outside the triangle, bounded by the rectangle, is also made from two half rectangles in blue and green. The two areas are the same, so it follows that the triangle area is half the larger rectangle area. We can prove this mathematically if we first label the equal blue triangle areas by the letter X and the equal green triangle areas by the letter Y. The large rectangle area equals the sum of the triangles making up the two enclosed smaller rectangles. So we have R is equal to X plus Y plus Y. Collecting the X's and the Y's, R is equal to 2X plus 2Y, and if we factorise this by taking a 2 outside, we have R is equal to 2 bracket X plus Y, close bracket. Now the triangle area, call it capital T, is equal to X plus Y. So you see, R, the rectangle area, is equal to 2T, twice the triangle area. So, making T the subject of the equation, T, the triangle area, is equal to the rectangle area divided by 2. T is equal to R over T, over 2. So if the rectangle has a base B and a height H, its area R is BH. It follows that the area T of the enclosed triangle is a half R or a half BH. That is, the triangle area equals half the base B times the height H. The other method for calculating triangle area concerns two sides and an included angle. Now we know that area can be calculated from a half base times height. So, given the base and an angle connecting the base to another side, we can calculate the height of the triangle. If the angle is theta, the base B, the adjacent side A, and the height H, then H equals A sine theta. So if we have capital A for area, A equals half the base times the height, A equals half BH, which equals half B times A sine theta in brackets. If we remove the brackets, we get a more memorable equation. We get A equals half AB sine theta. In other words, the area is half the product of the two sides multiplied by the sine of the included angle. Now if on the left we have side C and angle alpha, the area A is given by A equals a half BC sine alpha. Likewise, if we have angle beta at the top, the area A is given by A equals a half AC sine beta. Now the following two examples should put all this together for you. Example number 1. A regular pyramid has the top four sides made from equilateral triangles of side 10 centimeters. With reference to a right angled triangle containing angles of 60 degrees and 30 degrees, calculate the surface area of the pyramid. Answer to 2 decimal places. The first thing to do is to draw a sketch. Put the angles in, 30 degrees and 60 degrees, and the sides, the bottom one, 1 unit, the right hand side root 3 and a hypotenuse 2. Remember in Pythagoras, 2 squared is equal to 1 squared plus root 3 squared. In other words, 4 is equal to 1 plus 3. The surface area of the pyramid is shown as a net. The sides of the equilateral triangle are 10 centimeters each, and the sides of the square are 10 centimeters each. If we now drop a perpendicular from the apex of the top equilateral triangle to bisect the bottom side, the bottom side's 10 centimeters, it divides it into two fives. We have the 60-degree angle and 30-degree angle like the right angle triangle we were given, and you'll see they are congruent. In fact, one is 5 times bigger than the other, so the scale factor is 5. Okay, so here we go. The surface area is equal to 4 times the area of a single equilateral triangle plus the area of the square at the base. The area of the square is 10 times 10, which is 100 square centimeters. The area of a triangle is equal to half the base times the height. Now the scale factor, as we saw earlier, for the triangles is a factor of 5. So the height is equal to 5 times root 3, which is 5 times 1.732, which comes to 8.6603. So we have the area of the triangle is equal to half, that's 0.5, times 10 times 8.6603, which equals 43.3015. The surface area of the pyramid equals 4 times the area of a triangle, which is 4 times 4.3015, plus 100, which gives 173.206, plus 100, which gives 273.206. So here's our answer. The surface area of the pyramid is equal to 273.21 square centimeters to 2 decimal places. Example number 2. A triangle has sides of 12 centimeters and 19 centimeters with an included angle of 74 degrees. Calculate the area, answer to 2 decimal places. Here's our included angle, 74 degrees. One side 12 centimeter and the other one 19 centimeters. The first thing we do is drop a perpendicular from the apex of the triangle, makes a right angle with the base. This is the height of the triangle. And next we'll write down the information that we've been given. We're given that the base is equal to 19 centimeters. We need to work out the height. The height is equal to 12 sine 74 degrees. Okay, using our equation for area, area equals half the base times the height. We get 0.5 times 19 times 12 sine 74 degrees, which is 0.9613. Working all that out comes to 109.5882. So we can write our answer. The area of the triangle equals 109.59 square centimeters to 2 decimal places. And that's all, folks. In the next tutorial, we will examine how the sine, cosine and tangent ratios change as theta completes a full circle of 360 degrees. As usual, there will be lots of worked examples to help you out. Anyway, thank you all for watching. Oh, and don't forget to subscribe. You don't want to miss the latest vid. See you soon.